Hi, thanks for attending our presentation today on prevention and early detection, error proving with electronic device history records, or eDHR as they're called. Today we intend to provide some information to you on how medical device companies are being more proactive in using eDHR as a strategic solution for their organizations. I'm Jeff Russell in CAMSTAR's Global Medical Device Practice. I'm joined by Dan Matlis, who's President and CEO of Axendia, as well as Greg Rubino, who's in the technical sales organization with CAMSTAR. And today we intend to walk through some information for you, starting with Dan Matlis, who's going to talk about some industry trends that they've seen through some recent industry surveys they performed. Then we'll transition into going through understanding what paperless manufacturing is, current state challenges, future state potential and benefits using a system like eDHR, and finally concluding with a demonstration on how eDHR systems actually work. Dan, I'm going to hand it over to you for some of the industry survey information that your organization's collected.
Thank you, Jeff. What we'll do today is talk to you a little bit about some of the key findings from a recent research study where we looked at the state of process improvement initiatives in the medical device industry. So one of the key challenges that our industry faces is that we're really drowning in inactionable data. There's a lot of paper systems, and our research of 239 medical technology industry leaders shows that we're really drowning in this data. We suffer from a syndrome that we like to call data-rich, intelligence poor, where we're really unable to gain the benefits of the data that we collect as an industry. As a result of that, the number one type of waste that organizations are faced with today is defects. 88% of those who responded to our survey said that defects have a high or medium impact on their organization. And the challenge is that we're not really error-proofing our processes. We're really not driving to right first time because of the fact that we don't have the right technologies or the right systems to support that. And as a result, we have a lot of waste. Now, one of the key issues to talk about here is that these challenges really span across company size as well as geographic location. And whether you're talking about a mature market or a mature company or an emerging market in a startup company. So to take it a little bit further, the research confirms that the primary driver for implementing process improvement initiatives are reducing defects and also improving regulatory compliance. And these two really go hand in hand. Companies are implementing a variety of process improvement initiatives in order to combat waste and reduce costs. But in our industry, the primary drivers are reducing defects and improving regulatory compliance. And this is not surprising, given the fact that when we ask our survey participants, what is your company's approach to dealing with operational manufacturing issues? The vast majority, 55%, say that they use reactive or firefighting approaches to addressing issues most of the time. And as you can see, predictive approach based on analytics, based on intelligence, is only 10%. So these trends are really something that we need to address as an industry and make sure that we are shifting to a more proactive approach and are able to capitalize on the systems that we have. So what is the formula for success? How do you, as a medical technology company, ensure that you're making the perfect product every single time? And that really boils down to having the right materials, the right personnel, the right people, the right skills, the right training, along with the right machinery, the right equipment, ensuring that you're doing it in the right facility, and also following the right processes and procedures. And finally, the most important thing is having the right measurement and testing to ensure that you're actually closing the loop and feeding further processes and making decisions based on fact. And since we are in a regulated industry, having the right documented evidence, that electronic device history record that proves that you have, in fact, made the right product using the right materials, personnel, machinery, processes, measurements, and testing. And this is extremely critical because it means we need to error-proof our systems. We need to shift into a proactive approach in order to address the issues, the defects that we face as an industry, and ensure that we're making the perfect product every time. So what do? The call to action here is medical device organizations really need to transform the way they do business. And as I mentioned earlier, the trends and the issues impact small startup companies all the way up to companies with over $10 billion worth of revenue. The issues are consistent. So the number one call to action is medical device organizations need to shift from the current reactive approach to addressing issues and shift to a proactive and eventually a predictive approach based on intelligence and analytics and actual data. The second important point to transforming the business is stop chasing defects and really focus instead on achieving on-demand visibility across all the constituents within your organization. And those are both internal as well as external constituents, from raw materials and sub-assembly components all the way through to the customer. The next point is improving processes by error-proofing, by minimizing and eliminating the opportunities for error by having appropriate systems that actually prevent somebody from doing something they're not supposed to. Really getting to the root cause analysis. A lot of times in our industry, we're going through the CAPA process and we're going through the motions as it relates to CAPA. And we find the corrective actions and we believe we have identified preventative actions, but very seldom do we truly get to the actual root cause and minimize the opportunity for that root cause to reoccur. We also need to eliminate bottlenecks and really take out those non-value add activities which actually create additional opportunities for error. By implementing these changes and transforming their businesses, medical device companies can really increase customer satisfaction and brand equity while lowering costs and improving quality. So the final thought here is if you implement the right system that provides you an appropriate electronic device history record, you're really making the perfect product every time. And with that, I'd like to turn it back to Jeff to continue the presentation.
Dan, thanks for sharing that information that Axendia has found doing the market research. I wanted to continue on your thoughts there about moving from a reactive environment to a more proactive and even predictive environment, and pose a question that one of my colleagues, I heard them ask recently, and I thought it was perfect for this presentation. And that question was, when you wake up, are you thinking about preventing problems or just managing them better? The real question is, when you wake up, are you thinking about being proactive or reactive to production issues? And we just want to put forward and present how medical device companies have found a better way, and that you can step back from the battle that you're currently fighting to evaluate alternatives to paper-based manual systems such as electronic device history records. So let's first begin by talking about the problem with paper. This discussion is all about electronic device history records, so it makes sense to start here and explore what are the problems with paper. So if you look at this paper DHR, representative of any DHR on any manufacturing shop floor, where are the problems? What's wrong here? Well, it's not evident looking at this page where the errors are, but believe me, they're there. It's not relevant to talk about exactly what the errors are on this paper device history record, but to point out that the manufacturer showed these errors to us. We also had another explain what the opportunities for documentation errors mean in their organization by looking across their product lines, which are represented at the top of the page here, multiplied by the number of work orders created each year, multiplied by the pieces of paper in those work orders, multiplied further by the quality data collection points per page, and finally, the opportunities for errors, which are over almost 5 million opportunities for errors annually when it comes to the documentation. And even at 99.5% accuracy, they pointed out that there would still be 24,000 documentation errors. Now, in this example, in the previous example, we just talked about the number of documentation errors that would exist even at 99.5% accuracy in a paper-based environment. I think most people on this presentation listening would agree that 99.5% accuracy in a paper manual-based environment is probably not reality. The accuracy is actually much lower. So the challenge with paper systems is that they lack the ability to adequately prevent errors at each and every step of your manufacturing operation. And in those operations, you need to make sure that the machine is properly qualified, that the operator is trained for the work they're doing, that the right procedures are being followed each and every time, and the right data collections are occurring, whether that be a test value that's being recorded, a pass-fail value that's being recorded, or a signature that's being recorded in the DHR for work that's being done. Was the right material used, the right components issued for this product? And finally, is the documentation perfect? Well, the problem with paper-based systems, and if you think about this having to occur at each and every step in your operations, is think about the complexity of that problem when it comes to times the number of operations on the production line, times the number of lines in your production facility. And if you have multiple production facilities, times the number of plants that you have. Finally, times the number of DHRs annually that are produced as a result of manufacturing your products. Well, this is also the paper-based systems. Another problem is that they're very costly in terms of just simply the overhead that's required to push the paper through the process in terms of FTEs, full-time equivalents, or individuals, the actual cost of the paper, toners and cartridges themselves, storage, those types of costs. Another costly problem for manufacturers is that these paper manual-based systems are really low value to no value add in the process. Also, in not adequately preventing errors from occurring, they can be expensive as it relates to product quality issues that manifest and show up in terms of scrap rates and low yields. And finally, the latency that the paper introduces into the process. We've heard many medical device companies say that they can make product much faster, that they can actually push the paper through the process, which actually slows down the production, the final release, and shipment of products to the customers, which can be costly in terms of excess inventory that's being carried as a result of that latency, and certainly in terms of customer sat if orders are held up and late to the customer. And finally, it can be a risky problem. Again, back to the documentation errors that we discussed earlier. If the DHR isn't perfect each and every time, that certainly exposes medical device companies when it comes time for audits. And it's also a risky problem in terms of the number of ECOs, engineering change orders, that are being presented to the shop floor. The only constant is change in medical device manufacturing. And as the rising number of ECOs and new product introductions occurs, this again just makes that the risk of introducing new products, new processes, and new procedures that much greater in that operators understand the work they're to perform, the new procedures they're supposed to follow each and every time across all your production facilities. And finally, the impact of brand is certainly a risk. That carefully cultivated brand, any time that there's an issue, a product quality issue, there's a potential risk to the brand. So the alternative we wanted to talk about today is eDHR. So let's look at the alternative and exactly what an electronic device history record means. So what is paperless manufacturing? That's eDHR is replacing all your paper-based manual processes. No paper travelers anymore. Paper manuals, paper drawings, they go away. Your orders are downloaded automatically from the ERP system and presented to the shop floor. And operators are presented with the orders that are properly sequenced for the work they're supposed to do, whether that be by priority or due date as examples. Operators have visual cues such as key performance indicators, KPIs, at their work cell. Drawings and SOPs can be viewed online and linked to the most current revision. The eDHR system, and this is most important, prevents errors and alerts when issues potentially arise. And should they arise, nonconformances can be created and products can be put on hold. And when issues do occur, containment can happen quickly. You can find those suspect products very quickly on your shop floor to contain them and put them on hold so they don't make it out the door as quality escapees. Your in-process manufacturing reviews can be completely eliminated with a self-auditing device history record. And when it comes to the final DHR review and release, that time can be dramatically reduced. Our benchmark's around 80% for medical device companies in that one area alone. Production and quality organizations will have instant access to device history records when required. All the data that's been captured in the process and formerly locked away in the paper and in storage is now available online for trending and analysis. And finally, management and supervisors and everyone in the organization can be presented with real-time dashboards about information about how production is occurring today. So the foundation of an eDHR system, and you'll hear us refer to the 5 M's throughout this presentation, is the 5 M's of eDHR control. The eDHR executes and enforces to the DMR, the device master record, each and every time, ensuring that the right man, the first M, is working on the right machine, the second M, following the right methods, the third M, doing the right measures, the right data collections, the right signatures, the fourth M, and finally, using the right materials, the right components each and every time, the fifth M. With an eDHR, product moves through a workflow, such as the one that's represented here. And at each operation, operators are guided through their activities they need to perform, and that helps enforce the 5 M's. For example, orders are started, properly sequenced for the operator to work on. Line clearance activities and clear work instructions are presented to the operator for the work they need to perform and the sequence that they may need to go through to perform those activities. Data collection activities occur each and every time, whether that's a manual entry of a data or a test result, or even an automated data collection from a piece of production equipment. And finally, components are issued, the right components, preventing component mixes each and every time in the manufacturing process. And the result is an error-free eDHR. We looked earlier at the paper DHR that had multiple errors on the page. In a electronic environment, a self-auditing eDHR, those opportunities for errors go away, zero documentation errors. And if you look at that result and the benefit for a medical device company like Boston Scientific who's using eDHR, they presented about their experience just in an audit where their auditor, you can read the quote here, commented about how it was a pleasure to see that the automated system, the eDHR, allowed for quick retrieval and complete retrieval of accurate data. Another result with better enforcement and error prevention around the 5 M's is the fact that companies are consistently reducing the number of nonconformance and deviations that occur in their manufacturing processes. With better enforcement and right first time, they're seeing less nonconformances. You can see Terumo's experience here around their 41% decrease in nonconformances on the production floor with better enforcement. And what that yields is it reduces the time associated with investigations of those nonconformances, absolutely reduces the waste and the rework activities that are associated with these completely preventable nonconformances, which stabilizes manufacturing processes for more predictable manufacturing output. And again, continuing with Terumo's experience, the result of now more consistent product quality yields in better customer experience, fewer product complaints coming from the field. This is real data from their trend over time after their implementation of an electronic device history record system. Another result of getting paper out of the process and implementing an eDHR is alleviating the bottleneck that the paper represents. So you can see represented here on the screen the pictures and piles of paper, the files, the folders, the cabinets. I'm sure everybody on this call is familiar with this environment. Getting rid of the paper allows these medical device customers and medical device users to move from that process where they review each and every page of the DHR, the paper DHR, to a review by exception environment in an electronic system where they only look at the exceptions that may have occurred in the production process, which greatly reduces the time to review and release product. And if you look at the experience, for example, that Roche has in a presentation that they provided, that resulted in a 75% reduction in the review time and an overall over a 50% reduction in the release cycle time in terms of days. What does that mean? That means they're able to get product to their customers more consistently, more quickly. Improves their order to cash cycle. Think about it in terms of revenue recognition for the quarter when you can ship more product versus having to have that cutoff that every manufacturer has to have every quarter around review and release of product. And also, finally, in terms of the latency we talked about earlier, being able to accelerate that review and release cycle and the opportunities that it represents for inventory reduction. Another improvement with eDHR systems is taking all this information that's locked away in these files and folders and boxes, which ultimately go off to an off-site storage facility, and having all that information available online for trending and analysis, and being able to provide reports, whether that's the actual DHR report online or management reports and dashboards with drill-down capabilities, again, to keep the finger on the pulse of how the manufacturing operations are happening today. Here's examples of medical device customers who are using this information and displaying it on the shop floor for supervisors and operators to see, again, just how are we doing today. Manufacturers who are using eDHR are driving real manufacturing performance results, whether it's redeploying or even eliminating individuals and activities that are associated with non-value add activities, whether it's these in-process manufacturing reviews that completely go away, or just needing fewer people to do review and release activities, being able to redeploy those individuals to more value add activities for the company. Also, in terms of with better enforcement, preventing errors from occurring. The example here, preventing a scrap opportunity that would have resulted in $250,000 of a lot being thrown out on day 2 of using the system. And finally, again, we mentioned earlier the latency in the system being taken out and the opportunities for inventory reductions and cycle time reductions. Just again, real organizations, real improvements by use of electronic device history record system. And finally, think about the brand protection. More consistent product quality, right first time, each and every time. Better consistent product quality in the field, at customers, protecting that carefully cultivated brand. Boston Scientific presented what that meant to them as an organization in terms of recall exposure reduction. Almost a 70% reduction in recalls and exposures to potential recalls with better enforcement in the manufacturing process. and other benefits such as there's reductions in the need for CAPAs with better enforcement, better prevention on the shop floor. So let's move on to demonstrating the 5 M's in an eDHR system. So first, just to tee up the demonstration, let's discuss the capabilities that are needed to enable eDHR. Well, first of all, orders are started by the ERP system, and of course that product will go through certain value-add activities which result in an end product that's shipped off to customers. But let's talk about the different capabilities during that process, from the order being presented to the shop floor to the product being shipped and released to a customer, that need to occur, the enforcement of the 5 M's that we'll demonstrate. Well, the first M is the material enforcement. This enforcement enforces that the right materials per the bill of material or recipe is being used and consumed on the shop floor. The correct components and the right revision each and every time, the correct quantities or volumes each and every time, and that those products, those components and materials have not expired. An eDHR system, just to mention, should be able to support multiple different manufacturing processes. Whether you're a large or small medical device company, we see just consistently that there are, in many cases, multiple manufacturing styles that are present even under one roof of a manufacturing company. So let's take a look at the first enforcement, which is material enforcement.
Now we're going to discuss material enforcement. We are looking at the component issue screen, which provides the traceability between the serial or lot numbers of components to a finished good, but it also enforces a number of quality and GMP rules along the way. For the finished good items shown, the system provides a bill of material list that is applicable to the assembly operation. I can scan the barcoded label of a component to enter its lot number, and the system will validate whether the lot that was entered is valid per the bill of material. As we see from the error message, this lot of materials does not match any of the items on the bill of material, including any substitute or alternate items. Now we'll scan a different lot number. This time the material is expired, and we are not able to use this lot. Finally, when I scan a third lot, we find that this lot is acceptable according to all of the business rules that are being enforced. Camstar Manufacturing provides additional enforcement around non-conforming materials, quantities, LIFO or FIFO usage, and more to ensure that we are building quality into the product.
The second enforcement that we'll demonstrate is man or operator training and certification enforcement. In this scenario, the system will ensure that the right operator with the right training and certification is performing the work at that process, for that product, for that spec, on that piece of equipment. Of course, this ensures that product quality is the product being built is of high quality each and every time because the operator has been properly trained. It also ensures regulatory compliance. So let's take a look at the man enforcement in the demonstration.
Now we're going to discuss man or operator enforcement. We see that Ali operator is logged in at the BPM assembly operation and is looking at a schedule or dispatch list of items to work on. Ali will select the first item in the in-queue or pending list and will click on the Move In or Start button to indicate that he's ready to start work. We see from the error message that Camstar Manufacturing verifies whether or not Ali is trained on the SOP for this part number, which he is not. Now I'll log off of Camstar Manufacturing and log back on as Andy Assembler. When Andy attempts to move in the same item, we see that his certification on the SOP is up to date and he is able to transact in the system.
Okay, so moving on to the third M enforcement would be machine enforcement. And similar to the operator training and certification enforcement, in the machine enforcement, we will see the system ensure that the resource that's being used at this step in operation in the manufacturing process is appropriate for the work for the product that's being manufactured, and that's within its schedule. Again, as we showed with the operator training and certification, this will, number one, ensure product quality each and every time because, of course, you want the machine within its proper calibration or maintenance period to be producing consistent product quality. And again, it also ensures regulatory compliance. So let's look at the demonstration for the machine enforcement.
Now we're going to discuss machine enforcement. We are looking at the move-in screen, which allows the operator to indicate that they are starting work on a particular unit or lot. The first action is to select a piece of equipment or resource in CAMSTAR terminology that the operator will use to assemble the product. By clicking on the resource drop-down list, we see the first aspect of machine enforcement. The system only displays the valid resources as defined by the SOP or recipe. When the operator selects Machine A1 and clicks on the Move-In button to start the item, we see the second aspect of machine enforcement. The system provides an error message indicating that this machine is past due for preventive maintenance. When the operator selects Machine B2, we get a second error message, this time indicating that the machine is not available. Finally, when the operator selects the third machine, we see a confirmation message indicating that the item has been started and there are no pending or past due calibration or maintenance activities for this machine.
The final limb to demonstrate is the measure enforcement, where we ensure that all data is complete. I'm sorry, this would be the fourth, where we ensure measure enforcement, where all data is complete. This ensures that throughout the process and at this step in the operation that the operator is collecting all the information that they need to collect, whether that's a test value, a pass-fail value, or even an electronic signature, and that data collection is within spec. This is the difference between a paper-based system and an electronic system, whereas in paper, you collect a data value, there's no feedback to the operator around, okay, was that within spec? Within a system like an eDHR, there's an immediate feedback to the operator that the data that collected is outside of the specifications. We'll also take a look at being able to prevent scrap with statistical process control, or SPC analysis, to provide early warnings when a process is trending out of control. And the whole idea here is that, again, putting better enforcement in the process, you're able to prevent those quality escapees from occurring. So let's take a look at the measure enforcement.
We are now going to discuss measure or process control enforcement. We are looking at an inspection screen which enables an operator to measure and record the diameter of a particular unit and view an SPC chart. On the screen, the system displays the unit of measure and the upper and lower spec limits for the measurement. This value could be automatically entered through an interface to test equipment or a measurement device, or manually entered. Data that is entered is immediately compared against the spec limits, and the spec limit that is violated is highlighted. If I were to submit this value to the database, the system will record this unit as failed and can automatically create a nonconformance report. If I change the measurement to a reading that is intolerance, we see that the red highlighting is removed. When I submit the entry, the SPC charts are automatically displayed. In this instance, we are looking at a combination of X bar, R, and process capability charts. On the charts, blue dots are good, while red dots are an indication that an SPC rule has been violated, such as 6 points trending in an upward direction even while in spec. When a rule is violated, CAMSTAR Manufacturing can automatically trigger an out-of-control action plan, or OCAP, such as placing the unit on hold, changing the status of the piece of equipment from up to down, or providing an email notification to an engineer or maintenance technician. CAMSTAR's SPC module provides an additional level of process control enforcement over and above the simple tolerance enforcement, as it can spot trends and alert the appropriate personnel before out-of-spec material is even produced.
And the final M to demonstrate would be the method enforcement. This is ensuring that the right routes and processes and tasks occur each and every time in the manufacturing process, whether it's an operator completing their assigned task at an operation or the product moving through the defined workflows we showed earlier and through the proper workflow based on the product, revision, based on potentially data collection values, managing where the product goes next in an operation, and even managing and recording rework steps in the process. So we'll see with method enforcement that, number one, this should support a complex process where alternative materials and routes and rework procedures are the norm and accepted. We also need to be able to ensure that MRB activities and holds, reviews, and dispositions occur, and that any planned deviations are enforced. And finally, with complex manufacturing processes where products may be split and merged and then even bend or graded as a result of a test value, the methods and enforcement of all these processes, procedures, and routes need to occur each and every time. So let's take a look at the method enforcement demonstration.
Now we're going to discuss method enforcement, focusing on procedural enforcement. Camstar Manufacturing provides the ability to link to a document management system to display work instructions or SOPs. But since those instructions are embedded in a Word or PDF file, the system can't enforce that the operator is following the step-by-step instructions contained in the procedure, and thus prevent the operator from making a mistake. That is where electronic procedures come into play. We are looking at the e-procedure screen with a 3-step procedure. Having those procedures in a structured format rather than an unstructured Word document allows Camstar Manufacturing to enforce whether or not an activity is required or optional, can be performed once or multiple times, or must be performed in a sequential or random order, and that the data that is captured is within spec. So, for example, if the operator selected the 3rd task and tried to execute it, the system provides an error message stating that you cannot skip a required task. Going back to the 1st task, we see that the instruction is to remove all materials from previous orders and clean processing surfaces per SOP 100. As was mentioned before, Camstar Manufacturing has the ability to link to PLM systems to display SOPs, work instructions, CAD files, etc. The operator can review the cleaning instructions in the SOP, perform the line clearance activities, and then acknowledge the completion of the line clearance. As you can see, the system records the operator, the date and timestamp with every action. On the next task, the instructions are to visually inspect the BPM assembly and indicate pass or fail. As you'll see, the system tracks the status of each task as it's completed. In the last task, the inspector will enter both sample measurements and click on the Calculate button to see the results before clicking on the Execute Task button to complete the task. The system verifies that the data and calculation results are in spec. If not, the system can automatically create a nonconformance record or move the unit to a rework location depending on the methods you have configured to enforce.
So we've explored the 5 M's of enforcement in an eDHR system. Let's also look at the capabilities of the system to provide containment when there's issues in a manufacturing process, or the traceability, really the visibility that an eDHR system can provide now with all that information that was previously in the boxes, in the files, in the folders, on paper, very difficult to get at and retrieve and make use of, now available in the system. So let's take a look at that demonstration.
Now we're going to discuss traceability and reporting. The end result, or almost byproduct, of the 5M enforcement is a self-auditing DHR that ensures that both finished items and the quality records are compliant by the end of the production process. Users can view the DHR at any time online. The first page of the DHR shows nonconformances and failures in order to facilitate review by exception. The user can drill down into the nonconformance to see more details, such as failure, cause, and resolution codes. The subsequent pages of the DHR show all the activities that occurred for this unit, and similarly, the user can drill down again to see additional details, such as the component traceability information. In addition to top-down traceability, as shown in the DHR, Camstar Manufacturing provides bottom-up traceability as well. On the containment management screen, we have the ability to search for units or lots based on a number of different criteria. Perhaps you want to see all of the units that a particular operator worked on because of a training issue. Or perhaps one of the machines went out of tolerance and you need to know which lots were affected. Or perhaps there is a bad lot of components from a supplier. With this screen, you can search for the affected subassemblies and finished goods and place them on hold with a reason code. All of the data captured in the DHR can also be used to support production and quality dashboards that help run and improve operations. Here is an example of a production dashboard that shows OEE, throughput, output, and yield by month. The user can drill down into each of these charts to get more information. For example, we can drill down into OEE for a particular month to see the data by plant, then by production line, then by resource or machine, and then finally the availability, performance, and quality components of OEE for that machine during that month.
I want to thank Greg Rubino for preparing those demonstrations for us, and also want to thank Dan Matlis again from Axendia for kicking this presentation off with the industry findings that he has. And I also want to invite everybody who's listening to the call here, if you want to learn more about electronic device history record systems, visit camstar.com. There's a wealth of information available, including links to our customers and others who have eliminated paper from their manufacturing operations, replacing it with electronic systems. You can hear about their experiences on our website. Also want to invite folks listening to the presentation to consider attending an event that's being held on June 25th in San Diego. This is actually an emerging medical device company called Dexcom that is opening their doors for other medical device companies who are considering systems like eDHR to come in and hear their experience implementing and using an eDHR system. So again, more information on this event can be found on our website at www.camstar.com. Again, thank you for attending the presentation today. We hope you found it informative, and please visit our website, camstar.com, if you'd like to learn more. Thank you.